The Maya collapse. What ancient DNA is telling us for centuries, the fall of the ancient Maya civilization has been one of history's most enduring mysteries. Grand cities abandoned, towering temples left to the jungle's embrace. What happened? Did they vanish into thin air? Well, prepare to have your understanding challenged. Because a groundbreaking new study, published in Nature Communications, has just used ancient human DNA from the very people who lived through these dramatic times to unravel secrets we never thought possible. When we talk about the Maya collapse, we're often referring to the Terminal Classic period, roughly 800 to 1000 AD. This was when many of the grand cities of the southern lowlands, like Tikal and Calakmul, saw a dramatic decline in population and monumental construction. Drought, warfare, political instability, these have long been the leading theories for why these incredible centers seemingly emptied out. But these theories were largely based on archaeological records, pottery, and inscriptions. They told us what happened, but not always how it affected the people at the deepest level. Enter ancient genomics. Imagine being able to read the diaries of people who lived over 1,000 years ago, not written in ink, but in their very own DNA. This new study focused on 30 individuals from the city of Jaina in Belize, covering a period from the pre-classic all the way through the Terminal Classic and post-classic eras, essentially tracing generations through the collapse. By extracting and sequencing DNA from ancient teeth and bone fragments, scientists can now piece together family trees, track population movements, understand genetic diversity, and even identify disease markers with unprecedented clarity. It's like forensic archaeology, but on a grand civilizational scale. And the results? Absolutely stunning. Discovery 1. The decline began earlier. One of the biggest surprises is that population decline wasn't just a terminal classic phenomenon. The genomic data suggests a significant population decrease began much earlier than previously thought, around 650 AD, well before the traditional collapse period. This indicates a more gradual, long-term process, not a sudden catastrophe. Discovery 2. The Patrilocal puzzle. And here's where it gets truly fascinating and deeply human. The study found strong evidence of patrilocal residence. What does that mean? It means that women, upon marriage, were predominantly moving from their birth villages to their husbands' communities. We see this through mitochondrial DNA, passed down through the mother's line, showing far more diversity than Y chromosome DNA, passed down through the father's line. This isn't just about family structure. It's about social organization, alliances, and how communities maintained connections even as things were changing. Discovery 3. Adaptation, not just abandonment. The people of Jaina didn't just disappear. While their numbers dropped, the genetic evidence shows they adapted. Burial practices shifted from grand, multi-individual tombs to more personal, single-person graves, reflecting a change in social structure and resource allocation. They continued to bury their dead in the same locations, showing a continuity of cultural practice despite the demographic shift. Discovery 4. Resilience and rebound. Crucially, genetic diversity did decline during the population bottlenecks, but it later rebounded as people migrated into the area and intermarried. This isn't a story of complete vanishing. It's a story of survival, movement, and the incredible human capacity for resilience. So, what does this all mean for our understanding of the Maya collapse? It tells us it wasn't a single cataclysmic event where everyone just packed up and left. It was a complex, multifaceted process spanning centuries, driven by a confluence of factors: drought, disease, warfare, political fragmentation. But it's also a story of incredible human tenacity. Communities experienced population decline, adapted their social structures,